All right, hi everyone. Here is our last and final video. And for this video, we are going to talk about the square root function and what this graph looks like. So in order to talk about our inputs and outputs, we do have this really good understanding of what the square root is, right? You know, the square root is taking a value like 4, and we can view it as cutting it in half, but we really view the outputs as not always. It's cutting in half from the value that it was originally. So we're not just dividing by 2. It's a little bit different than that. But we've talked about square roots, we've talked about squaring numbers, and really we've talked about this idea of a radical since Algebra 1. So we should have a pretty good idea of a square root, and now we just have to match it with what its graph looks like. So when we talk about the square root function, it's really important that we kind of just discuss these nice values, right? Because we know that not every number is a perfect square. So for example, when we take the square root of 0, we just get 0, right? 0 is 0. But when we take the square root of 1, we get 1 because 1 times 1 is 1. Okay, great, perfect numbers, right? But then when we take the square root of 2, if you use your calculator for this one, this is really the only one we would need to, you get that the square root of 2 is like 1.414 with some decimals. So that's what I'm talking about, nice points. Like, okay, do we really want to graph something like that? Not really, right? So let's just kind of stick with these nice values now. The next perfect square is 4. Well, the square root of 4 is 2. The next perfect square is 9. Well, the square root of 9 is 3. And then obviously you can see where this is going, right? Half of 4 is 2. A third of 9 is 3. A fourth of 16 is 4. A fifth of 25 is 5. So like I said, it's not necessarily dividing by 2 or cutting it in half. It's looking at like that next phase of like that fractional relationship, right? 1 and 1 are wholes. 4 and 2 is a half. 9 and 3 is a third. 16 and 4 is a fourth. 25 and 5 is a fifth. 6 and 36 is a sixth. So as you can see, that value of the fraction, it's going to that next step each time. Okay, so great. Now though, let's take a look at what happens when we look at these negative values. Well, if we're looking at the square root of -1, we talked about this first semester. -1 under the radical gives you that value of I, right? An imaginary value. Now, this is a little bit different, right? So what we're talking about is this idea, right? And then we said, okay, well, -1 is I squared. What we're talking about here is that it's not a real number. It's not a real integer. So taking a negative value under the square root gets you something that's undefined, and that's something that we can't plot. Okay, well, maybe let's try a nice number like -4, right? -4 is a perfect square. Well, 4 is a perfect square, I should say. But still, because this 4 is negative, you do get an error in your calculator. Like if you just want to type it in to test that out, you do get an error. So as you can see, when we're looking at this side of our graph in terms of x, we have nothing to plot. So if we want to see what this looks like, we can plot 0, 0, 1, 1. Okay, 2 is like 1.4, so right there. 4, 2 is right there. A 9, 3 is like all the way right here. So as you can see, it starts to move like that. And it does gradually get higher and higher and higher, and it does increase, but it moves at a much slower rate. Because if you think about it, 16 and 4 is our next value. And so to go from 9 to 16, you're traveling, across x, and you're going pretty far, but really you're only raising y one more value. So it's definitely more of a longer incline than a steeper incline, if that makes sense. And then because you can't have anything that's undefined, really this side of the graph and down is really kind of off limits. There's no negative values that we have when we're talking about the square root function. And that's also in terms of x and y. You cannot have any negative values. So it kind of does affect what we see for our domain and range. Now, some key points, if you notice, really just start at 0, 0, 1 to 1. We can go 4 to 2. We'll just look at good numbers. 9 to 3. And if you notice, nothing happens over here because it is undefined. You can't even plot those points. So how that affects our domain and range is that our domain in terms of x only is heading to positive infinity, and it definitely starts here where x is 0. That's like a hard start, right? And then for range, it starts here where y is 0, and it moves up positively to positive infinity. And that's really all that can happen here. You can't talk about x in any negative values. You can't talk about y in any negative values because in a square root, that just does not happen, right? So for the square root parent function, we have to know that nothing happens on this left side of the graph. We have to know that it's like kind of like this half curve that just keeps gradually increasing and increasing. And we have to know that you can't have any negative values. So now, there is no video for the last page of this homework, okay? But you guys will see that you're looking at two different graphs here, right? Here we see the original parent function of x cubed. And here we see the new one, right? We don't know what the equation is. We know it's something that's cubed. But how would we describe this? Okay, well, it looks like it shifts right. Let's see, it looks like this is going up by 2, so that's 1, 2, 3. Okay, it looks like it shifts right 3 units. Okay, if you look right here, it looks like it has a reflection with the parabola, right? It also looks like this is a little bit wider. If you look, here's the parent function 2 to 4, 1 to 1. And if you look, it doesn't look like it's doing that. It looks a little bit skinnier. So clearly there's going to be some type of compression or stretch. So your homework for this video is to just describe what you see from the original parent function to the new one that's graphed. Tomorrow in class, we're going to go through this. We're going to talk about these keywords, but you guys know these keywords from Algebra 1 and from first semester of Algebra 2. Reflection, horizontal shifts, vertical shifts, compression, stretches, really anything. Even if you want to say it looks wider, I'll take it, okay? But you just have to describe what you're seeing visually, okay? So your homework is to talk about these 4 graphs. Tomorrow we'll keep moving. We're going to learn how to write the equations, and that's about it. All right, have a good night, guys.